Refer to your lesson plan. Week number 4, we will learn about how to analyze indeterminate thrust using flexibility method. And previous video, I've explained about the introduction about how to analyze thrust structure using flexibility method, and we have discussed one example with one DOI. For today, we will discuss another example, June 2018, question number 2, which is the question is look like this. June 2018, question number 2. We will analyze this structure, which is indeterminate thrust subject to 100 kilonewton, and they have pin support at A and pin support at D using flexibility method. Okay, first step, we will calculate the DOI. Okay, we will calculate the DOI. M plus R minus 2G. M member equal to 8 plus reaction equal to 4 minus 2G. Joint have a 5. So this for that structure, DOI equal to 2. Okay, when you have a DOI equal to 2 for thrust structure, you must classify this DOI whether under external DOI or internal DOI. Okay, first we determine the external DOI. How to determine the external DOI? This reaction minus n equal to 3. 3 means static equation for 2D. They have 3. So because for our structure we have 2 pin support. When they have a 2 pin support, so they have a 4 reaction. 4 minus 3 equal to 1. So they have a external DOI equal to 1. So when they have an external DOI equal to 1, total DOI equal to 2. Total DOI equal to 2 minus external equal to 1. So internal equal to 1. External plus internal must equal to total DOI. After you have determined the DOI, next we must determine our redundant force. Okay, in this example, for redundant force, we can choose dx and FBD. Why we choose dx and FBD? Because since your DOI, one external, one internal. When your DOI external means for your redundant force, for external you must remove one reaction. That's why you remove dx. Internal means you must remove force in member. So you must remove member. So that's why they remove force in member BD. For this example, you must remove one reaction and one member. Why one reaction and one member? Because one external, one internal. If your system they have 2 DOI for external, 0 DOI for internal, it means if they have a 2 DOI for external, it means you must remove 2 reaction. If they have 0 external, 2 internal, it means you must remove 2 members. But now because they have 1 external, 1 internal, that's why you remove 1 reaction and 1 member. So your primary structure look like this. When you remove dx, so at D here, for primary structure, now from pin, after you remove dx, they have roller support here, and you have removed member BD. That's why they have no member BD here, because you remove already to sketch your primary structure, because your primary structure must statically determinate. This is option number 1. Option number 2, you can remove AX and force in member AC. You can remove AX, means support at A become roller, and you can remove member AC. Okay. Normally for internal we will remove the member cross here, as long as your system statically determinate. Okay, you can remove whatever reaction and member as long as your member statically determinate. Normally for internal we will remove the cross member. Okay, so this is how we sketch the primary structure. They have option number 1 and option number 2, depend to the redundant force we have choose here. If you choose DX FBD, this is your primary structure. If you choose AX and FAC, this is your primary structure. Then this is a compatibility equation, general compatibility equation, when they have 2 DOI. Okay, delta 1, delta 2, this is we have discussed already. Next, we will sketch the principle of superposition. Principle of superposition when we choose DX and FBD as our redundant force. When you choose DX and FBD as your redundant force, it means you must remove DX and force BD from your actual structure. Okay, after you choose DX and FBD as your redundant force, it means you will remove this from your actual structure. This is your actual structure. Actual structure equal to primary structure plus redundant number 1 plus redundant number 2. Why you have 2 redundant force? Why you have 2 redundant structure? Because you have 2 redundant force. Why you have 2 redundant force? Because you have 2 DOI. You have 2 DOI, that's why you have 2 redundant force, and that's why you have 2 redundant structure. Okay. Primary structure, you remove the X, that's why from pin here now become roller, because you remove the effect dx, and you remove member BD. You remove member BD. That's why for primary structure they have no member BD. Okay. Then all the real load you apply on the primary structure only. Plus this is your redundant number 1. Redundant number 1 associated with DX, and redundant number 2 associated with FBD, force in member BD. That's why for redundant number 1 you apply 1 kilonewton at D in X. Why you apply at D in X? Because this is associated with DX. Okay, because you remove effect DX here, that's why you apply 1 kilonewton at D in X. That doesn't matter if you apply to the right or to the left. Plus this is redundant number 2. Redundant number 2, this is internally. We have discussed at the early stage. This is externally, that's why you apply load external. This is internally, that's why you apply 1 kilonewton internally. Replace the force BD you have removed just now to form your primary and redundant structure. So because you remove BD, that's why you apply 1 kilonewton in the direction of BD. Okay. After you sketch your principle of superposition, next we will calculate the axial force. We will calculate the axial force N0, N1, N2. N0 means we refer to primary, N1 will refer to redundant number 1, N2 will refer to redundant number 2. How to calculate this axial force? You can use the method you have learned from the previous semester. You can use the joint method. You can use the joint method to determine the internal forces N0, N1, N2. But here is the best is better we use simplified joint method, or normally students call it as easy method. Okay, this is after you apply that simplified joint method or easy method. This is how you determine all the internal forces. This internal forces for primary, this internal forces for redundant number 1, and this redundant forces for redundant number 2. The way how to determine axial force for primary, redundant number 1 and redundant number 2, I will explain detail in next video. I will explain detail in next video how to analyze this 1, 2, 3 structure using simplified joint method or easy method. So due to that, I will continue after we determine this N0, N1, N2. Next, after you have determined this N0, N1, N2, next you tabulate in table form. Tabulate the table form. Since we have 8 members, AB, AC, AD, BD, BC, CD, DE, CE. You must tabulate all of the members here. 1, 2, 3, 4, 5, 6, 7, 8. Length of every members. Tabulate the AE for this example because AE constant, so I leave it blank here. I will consider AE later. N0 means axial force for primary structure. You tabulate here based on the calculation from this structure. For example, this member AD, this member AD 100. That's why this AD, you got 100 here. Why negative? Because this is compression. When the arrow toward to the joint, it means negative or compression. Okay. For this example, this member means member DC. Member DC 58.3. Member DC, where is the DC? DC 58.3. Why positive? Because this arrow toward this joint. Okay. Because arrow not to the joint, so that's why this is considered tension and positive value. Similar to this member BC and BA. BC, BA, they have a 0 value, that's why BA and BC, BC, BA, they have 0 value here. Similar to N1, similar to N2. So you tabulate all the axial force value here. Okay. Then next you can calculate value delta 10, delta 20, F11, F12, F21, F22 here. Okay, how to calculate this value? Delta 10, you can refer to our note you can refer to our note. They have a formula how to calculate displacement for displacement for 10, 20, 11, 12, 21, and 22. The equation is n1 multiplied by n0 multiplied by L. Okay, you have a value n1 here, n0 here, and L here. You just multiply n1, n0, and L because they have zero value. That's why 0 here. Okay, similar to member AC, similar continue with member AD, n1 multiplied by n0 multiplied by 4 minus 400, and you continue for BD, BC, CD, DE, and CE. Then you will sum up all of this, so you got this value minus 400. Okay, minus 400. Similar to delta 2, 0, it means n2 multiplied by n0 multiplied by L, n2 multiplied by n0 multiplied by L. Okay, so you tabulate all the value for AB, AC, AD, BD, BC, CD, DE, and CE, and then you sum up this value. You got a 600 here. Then you continue for F11. F11 means n1 multiplied by n1 multiplied by L. You got this value. F12 to 1, you got this value, and you total. And F22, it means n2 multiplied by n2 multiplied by L. n2 multiplied by n2 multiplied by L. So you got this value. Then you total, you got a 16.72. Okay, 16.72 for F22, minus 2.4 for F12 and 21, F11 for delta 20 600, and delta 10 minus 400. Okay, after you have determined all the displacement here, this value, then you substitute into your compatibility equation. Okay, this is your compatibility equation. Okay, you substitute here delta 10, delta 20, F11, F12, F21, F22. This is your redundant force, your unknown. Okay, don't forget about your 1 over AE here. Okay, we put outside this AE because this is a constant value. Okay, if you have a different value of AE, please consider here. Okay, then this is your compatibility equation. We assume they have no support movement. That's why 0 here. They have no support movement. They have no displacement. Whether in dx or in member BD. So you can solve this. You press your calculator. You have a dx equal to 85.86 kilonewton and FBD equal to minus 23.56 kilonewton. It means this is your redundant force. dx and FBD. Okay. Then after you have determined your redundant force, because now your objective to determine your N axial force for actual structure. If you refer to principle of superposition here, just now you have calculated N0. It means axial force for primary, axial force for redundant number 1, axial force for redundant number 2. But axial force for actual structure not calculate yet. This is symbol by N. You cannot calculate this value of N because this is indeterminate structure. That's why you must determine dx and FBD first. After you have determined dx and FBD, then you can determine N. N equal to N0 plus N1 multiplied by dx plus N2 multiplied by FBD. just now you have determined the X and FBD. So next you can determine your N. This is N for actual structure. This is your objective, to determine N for actual structure. So this N for actual structure I already tabulate in our table, in the table form here. This is N for actual structure, because N here for primary, N here for redundant number 1, N here for redundant number 2. Then you have calculated your redundant force. After you have calculated your redundant force, then you can determine your N. How to determine this N? This N equal to N0 plus N1 multiplied by dx plus N2 multiplied by FBD. dx and FBD already determined here. So how to determine this N? 50.26. Okay, this N 50.26 equal to N0 plus N1 multiplied by dx plus N2 multiplied by FBD. It means, because this is 0, it means minus 0.8 multiplied by minus 23.56. So you got the, is it 50? Okay, it means you apply this equation, N equal to N0 plus N1 multiplied by dx plus N2 FBD, so you can determine axial force for every member AB, AC, AD, BD, BC, CD, DE, and CE. Okay, you can calculate this. If you got a different value, might be they have writing error somewhere here, but please recalculate this value by using the formula I mentioned to you all. N equal to N0 plus N1 multiplied by dx plus N2 multiplied by FBD. This is how we determine this N for actual structure. Okay, but please bear in mind, this flexibility method, the objective is to determine the redundant force. After you have determined the redundant force, then you can determine your actual axial force for actual structure. Okay, then question C, the same question, but here they have support D slip 10 mm to the left. Support D, they have a movement in X direction 10 mm to the left. Then you need to reanalyze member forces in thrust structure. Member forces in thrust structure means you refer to N for actual structure. So the other value remain. As we discussed when we learn for beam and frame. So you must apply your compatibility equation. Now you must consider this value, because now we have a support movement at D in X. That's why they have a value here, because this is represent the equation number 1. This is equation for movement at D in X. Okay, at D in X. So that's why, because they have a support movement 10 mm, that's why 0.01. Why negative value? Because just now clearly mentioned in our question, the slip to the left Okay, the slip to the left, support movement to the left, and your redundant force, you apply 1 kilonewton to the right. This is opposite direction. You assume positive to the right, and the support movement mentioned in your question to the left, so opposite direction. That's why they have a negative value here. So you recalculate value redundant force. So you got a new value for dx and fbd. Then after you have a new value of dx and fbd, you reapply in this equation. You calculate new n when they have a support movement. Okay, when they have support movement, you recalculate. So you have not mentioned here, I think. So better you calculate by yourself, and you can tabulate your answer here. Okay, thank you. Assalamualaikum. If you have any question, you can ask me anytime. Assalamualaikum.